Alright, this is lesson 94 for 8th grade, and today we're talking about inequalities. More specifically, we're going to graph inequalities. And I know we've done this before, but today is going to be a little bit different because we're going to add on just a little bit to it, and you'll see what that looks like. So we're going to start with an example here. It says we have graphed inequalities on a number line. In some situations, we consider pairs of inequalities, and that's the change here today. We're not just graphing one inequality, we're going to be graphing pairs of inequalities. For example, suppose we know that the heights of professional male basketball players range from 5 foot 5 inches or 65 inches to 7 foot 6 inches or 90 inches. This can be expressed on a number line with an inequality expression. No, you can come in. And that happens to look like this. Alright, they decided to put everything in inches. So we see our 5'5" is 65 inches, and then our 7'6" is 90 inches. So all of these are in inches here. And we know that the tallest person in professional basketball, and this is probably a little dated by now, but the tallest person is 90 inches, so that's where we stopped here. And the shortest person is 65 inches. Now, it's important to know that we include 65 inches and 90 inches in our graph. And the way that we show that is we have a closed circle on 65 and 90. Okay, closed circle. We've had open circles before, kind of like that, where we were not including some things, and we'll see what that looks like in a second. But we are including 65 and 90, so we want to show that by having closed circles. And here's how we would read the statement that follows. H is greater than or equal to 65, and H is less than or equal to 90. So another indicator for these closed circles is if we have the line underneath our symbol, that means and equal to, or greater to than equal to, or less than or equal to. And I think they go on and explain that right here. Alright, so H is greater than or equal to 65, and H is less than or equal to 90. So that means we can have anything in between here. Thank you. We can have any height in between 65 inches and 90 inches, and that's what is indicated right in here. That's why there's a line connecting the two, because it ranges in between those heights. Alright? So we could have somebody that was 75 inches tall, 76 inches tall, or maybe 66 inches tall. But we couldn't have someone that's 60 inches tall, nor someone that's 95, because they're not part of the range. Alright? And this just shows that how we got our intersection here. Anything bigger than 65 would be 65 and up. Anything lower than 90 would be 90 and less. So we take the intersection of these two, and this is where we get that, between 65 and 90. Alright, let's take a look at another example. Okay. Use a number line graph and an inequality expression to express the statement. The length of one side, S, of a triangle is greater than 2 and less than 8. So all we know is that one side of this triangle is greater than 2 and less than 8. So how do we express that side using inequalities? Alright. S is our side, and we know that S is greater than 2, but S is less than 8. And it doesn't say that it can be 2 or it can be 8. It doesn't say S is greater than or equal to, or S is less than or equal to. It's just that 8, or S, our side is less than 8, or our side is bigger than 2. It'd be like me asking you to choose a number bigger than 2. You wouldn't choose 2 because 2 is not bigger than itself. Or to choose a number less than 8. Okay, you wouldn't choose 8 because 8 is not less than 8. Alright, so we're not including 2 or 8. All we know is that our side is bigger than 2 and that it's less than 8. So what does that look like on the number line? We know that we're going to need to see 2 and 8, so let's get a range here. 1, 2, 3, 4, 5, 6, 7, 8, 9, That should be fine. And we are not including 2. Okay, so that's going to be an open circle on 2, not a closed. And we're not including 8, so open circle on 8. But anything in between there is fair game. So that would be our graph, alright? That indicates that the side is bigger than 2, less than 8, but it can be any length inside there. Okay? It can be 2.1, 2.5, 5.7, 6.872. As long as it's not over here or over here, we're good. Okay? So that would be our graph. This would be our expression. Okay? Graph this solution. Sometimes they don't give us a scenario, they just give us an expression and they want us to graph it. So now this is where the symbols come in handy, because we have -1 is less than or equal to x, or usually we like to read that in terms of the variable. So x is greater than or equal to -1, but x is less than 5. Okay? So we've got let's go okay. X is greater than or equal to -1. That is a circle right here. And that is a closed circle. Alright? We are including -1 because x is greater than -1, but it's also x is greater than or equal to -1. That's what that line under here means, remember? So x is greater than or equal to -1, but x is less than 5. And we don't see that line there, so we're not including 5. So we have an open circle. Alright, and then we just connect those. Just like that. And that would be our graph. Okay? That indicates all the numbers between -1 and 5, including -1, but excluding 5. Alright? So anything that's not in between here would not be part of the solution. Anything that is between there is part of the solution. So decimals, fractions, anything that falls in between -1 and less than 5 would be okay. Alright, one more. We have one more scenario, and that is an expression that looks like this. In our future, we're going to see some things in algebra where we get some kind of weird number line graphs, and this would be an example of one. Here we have t is less than 40, or t is greater than 100. Alright? So, I'm going to use red again. This marker is kind of going out on me. Alright, number line. I want to graph this. Alright. So let's go 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. Alright, should be alright. Now, we do know that t is less than 40, or it can be less than 40, I should say. But we are not including 40, it just says t is less than 40. And there's no line underneath it. So open circle at 40, and everything less than that. Okay. Alright, important to know that t can be anything less than 40. This can go into the negatives. It goes to negative infinity. So part of this solution, you could have negative 10,000, negative 987, negative 1 billion. It goes to negative infinity, alright? And likewise on the other side, except for which direction it goes, t is greater than 100, but it's not We don't have the line underneath it, so we don't include 100. We just know that t can also be greater than 100. So open circle. This one goes this way. Okay? So that includes anything greater than 100 up to positive infinity. And obviously then, anything from 40 to 100, these are not solutions. Okay? They are not part of the solution set from 40 to 100. Alright, so that's one of our kind of strange looking number line graphs. We've got them going this way, alright, with a space between that does not represent a solution. Alright, that is the main thing that we went through today, and we'll see you tomorrow.